guys. Well, here is our presentation about text summarization with sequence-to-sequence model, wherein in our team, Dear Stage and me, Gauri Shankar Aditya, and Bhuvan Reddy, we're going to explain. Wherein our objective about the project would be the goal where we create a smart tool about reading a long paragraphs and generating into a short summarize way in a different style, like normal paragraphs, bullet points, or two small paragraphs, or a mixed paragraphs or bullet points, wherein we used a machine learning model sequence to sequence to create it. Then our data sets from Hugging Face and Paper with Code, wherein the model sorry to make the model smarter and more flexible, we used augmented and the data set by creating four different summary styles. For each article of data set, we have used uh, additional three formats, which are a bullet points, two paragraph format, and paragraph plus bullet format. Next, wherein for the about model, where we have used sequence to sequence model with LSTM, which stands with the sequence to sequence, using a long short-term memory, wherein we have used two encoder and decoder. In this part, we read into input text, article, and tries tires to understand the important meanings and hidden in the word. Wherein the decoder, this part takes understanding and generate a short vision of text in summary. In the format, we want this model was trained on 1,000 words of article summaries as a pair of four formats. So it could learn how and good summary. We should also added special tokens like format paragraphs, format bullets, or models known what kind of summaries to create. Where in paragraphs, bullet points and paragraphs or two paragraph styles. These styles of model is very good at handling languages tasks where both the input and output text.
Hi everyone, this is Bhuvan. From now, I'll take over. Here, I am going to explain about the approaches used for text summarization. For doing text summarization, we can take two different approaches, which are extractive summarization and abstractive summarization. Extractive summarization is basically the older generation where in this method we used to take the whole paragraph, and in those paragraphs the important sentences or phrases were sorted out, and we won't even change the structure of the words, and it will just give you a shorter version of the same big paragraph by copying and pasting those important sentences and phrases. While coming to the abstractive summarization, which is the modification of this extractive summarization, in this method we use a new summary using its own words. The model will understand what it reads and generates an abstractive summarization, which means it will use all the new words and it will rearrange all the words. It will even generate new words to generate the summary. Now I'm going to explain the development process of the model. First, we started collecting data. We started the dataset collection from Hugging Face and the other sources, and then we just had a simple summary of the mod for every data set we used. We just had a simple summary. So we have virtually created four different types of formats in order to improve the flexibility of the model. And then we started text preprocessing and vocabulary creation using tokenization. And this tokenization was done by using the NLTK. And we have separated all the text into sub words, and those words were given specific numbers using this tokenization technique. And then we started building a model using this sequence to sequence LSTM. LSTM stands for long short term memory. And this is used because the model needs to memorize the whole paragraph in order to generate a abstractive summary. And here the main parts are encoder and decoder, which are used in order to make sure that the whole paragraph is understood by the model, and then it the computer can only understand numbers. So encoder is used in order to take these words and convert them into numbers, and then decoder is used in order to give the output where we require a summary of the paragraph. So here the decoder will convert those numbers again back to words and give us the sentences in summary format. For model training, we have used 25,000 samples which across 4 different formats. So it's 25,000 into 4, a total of 100,000 samples. And for model deployment for the front end, we have used Flask web application so that it will be easier for user interaction. And at last, we have evaluated and verified all the 4 formats of the summary types. Here, the technology stack we have used for this project development are NLTK for tokenizing the sentences and words, Pandas framework for handling and pre-processing the whole data set, and PyTorch for deep learning libraries, using deep learning libraries and building and training the encoder and decoder. Flask was used for like lightweight web framework, which is used to deploy the summarization, and Jupyter Notebook was used for model development, where we wrote all the code and everything. And TQDM was used for progress brought during training. From now, Dheeraj will take on.
Yeah, so thanks, Bhuvan. So I'll explain the working logic of model, like how the model actually summarizes the text given. So input text, we will give a paragraph, which is like a news article or a long sentence. The text, the words in that text will be converted to numbers because machine understands numbers. Now each word will be mapped to a number, so it's kind of a dictionary. Then that is given to the encoder, where encoder reads the full input and tries to understand the meaning by processing that numbers using the LSTM network. It provides a way, it tries to memorize that, and it creates a summary. And that summary is passed to the decoder. So decoder has a special format that we have given while training, which is format underscore bullets or format underscore paragraph. And using encoder's memory, it generates a shorter version of that particular paragraph or article that is given. And that particular summary that is generated will be in numbers. That will be converted back to words using an inverse vocabulary summary that we have generated. So this is the user interface. As you can see, we can scan the QR code to access the website. So in the summarize your text field, you add the long text or article or anything that you want to summarize. Basically, there are 4 options. One is paragraph, 2 paragraph, paragraph with bullets, and only bullets. So you select that particular option, hit summarize, and it will provide a summarized version below, which can be copied and used for our purpose. So this is the other option where we have summarized with paragraph and bullet points. This is just bullet points. Now, this model has certain drawbacks. So sometimes, as we have trained it with a limited set of data, like as explained before, it's 25,000 rows, which we have made in 4 formats. So totally 100,000 rows we have trained. So sometimes the meanings, it cannot understand the clear summary. So it will be out of context. And if input text is too long or complex, the summarization won't be proper. Then quality of summary depends on how well the model was trained. So here we had limited resources, due to which training is not up to the mark. but still we are able to generate good summaries. So when there are long or complex text, there is a chance that it will give uh, summaries with less context. Then currently it only supports 4 formats. So to add a new format, we need to again retrain the model with that particular format, uh, that particular token added to the summarization, so that training will happen properly. Then currently it's just trying to learn patterns, assign numbers to the words, and try to generate a meaningful summary. So it's patterns basically. It's not trying to understand things. So that part is also different. Future works, we can add more formats. Currently, there are only 4 formats. We can add something like question answer style or title generation, which also can be useful. Like if you provide a large paragraph, you can ask the more particular this model to generate a question and answers based on that paragraph. We can have better model architecture also. Like we can use pre-trained models, which can generate more accurate and meaningful summaries. We can update our model to handle longer text, provide multilingual support, and we can have a feedback loop also, so that users can correct things based on which the model can retrain itself, and the whole thing can be better. Explainability part, like currently for an end user, it doesn't make sense like how the summary is generated. So the explainability part can be better, like how we are generating that module. We not that module we can add saying that this is how the summary is generated. And one more addition is voice summary generation, where you can convert the summarized text into voice using uh, APIs like Amazon Poly and all, which converts from text to speech. So yeah, this is basically our work. Thank you.